geezer in the Rolls Royce, right? It was well sorted for time and distance. But from where I'm coming from, it's acceleration that impresses your mates. Oh, yes. And the better you can understand it and illustrate it, the more impressed they'll be. All I've got to do to get my speed is measure my time between the distance markers. You'll see them as I blast past.
If we measure the slope at different points along the graph, we get Andy's speed at those points. And we end up with a table of speed against time.
Now this is where the clever bit comes in.
If we plot these points on a speed-time graph, speed on the vertical axis and time on the horizontal axis, we can work out acceleration by measuring the gradient of the speed-time graph at any point.
In the manual, it says that my kicking motor does 0 to 90 in 9 seconds. But as you can see, I've souped it up, and it does it in 8.5. Nice one! Stopping distance is calculated with your distance time setup. So, if I slam on the anchors at 40 kilometres an hour, let's see what happens.
Although the time taken to stop doesn't change very much, the distance travelled increases dramatically. At 40 kilometres per hour, the car travels 9.8 metres and comes to a stop in 2 seconds. At 80 kilometres per hour, the car travels 25.1 metres and comes to a stop in 2.7 seconds.
Wicked! Oh, hi, Flash Hour is my name. When I'm not making wedges of cash in the city, I'm banging around a bike. It's fast, me, expensive, not myself. Now it's time for real acceleration and deceleration.
And just in case you're cheating, here's no captured live camera. Read it and weep. As you can see, the graph's completely off. I'm doing about 30 kilometres per hour. And eagle, at least a racetrack.
The mass of a motorbike compared to a car is much less, and this means that the bike gets started much more quickly. This shows in its acceleration. And apart from smashing the opposition when it comes to acceleration, emergency stops at the same speed as an equivalent car will also prove the bike to be much more efficient. So remember, speed equals distance over time, and you get that from your distance time graph. And time equals money, so I'm out of here. Acceleration is wicked, and you work it out from your speed time graph. If you're planning on making an emergency stop, the faster you're going, the longer distance you'll travel. Unbelievable stuff!